All right. So good afternoon to you all, and welcome once again to today's session. Today we are beginning our class with a celebration of our first certified AWS cloud practitioner, Benedine Okeke. So what I'm saying now is going to appear in the video as well. So congrats to you, congrats to you. And by the time we are done, everyone will be celebrated, everyone will be acknowledged, and this is not the end. There are several certifications within our training journey. So let's make sure that we are following the training, following the schedules, following the requirement of the training, and make sure that we build ourselves to become the tech professionals that Africa is waiting for. This is Rita Africa, and you are welcome, and we are happy to have you learn with us. Thank you so much, and we'll move on to today's lesson. So we are going to have day 17, and the content has been completed now for us to have this lesson in full. And this lesson is about the virtual private cloud and the networking infrastructure of AWS. This particular lesson requires you to pay a lot of attention and requires you to understand some key details. And our training has been designed to give you understanding. You know, a lot of things are very easy to go through. You can go through a whole course in 1 day, 2 days, 3 days. However, if you don't have foundational understanding or foundational knowledge, or if you don't have a background, you may not understand what you are watching or learning. And our goal here at Rita Africa is to give you understanding. All right. So this is why we take our time to go into details and help you have that foundational knowledge. This particular series of videos we are making, this is the 17, is not enough to cover all that you need for the training. And so additional resources from AWS will be included so that before you take the examination, you need to go through that as well. So at the end of this lesson, I'm going to give you that so that you go through, because we have verified and have seen that this is what you need. However, if you don't go through this particular training and you're a beginner, you may not have understanding. You may not have understanding. You may memorize things, you may chew and pour, as we say here in Ghana, for the examination, but you may not have understanding. And the journey we are on, we are not ending here, all right? We are not ending here. Whatever field you are in, you are going to make use of cloud, all right? We are not ending here at all. So our goal is not just the examination. Our goal is the tech knowledge that you are going to acquire and the skills, in-depth skills and understanding that you are going to acquire. And you can testify that this particular training has upgraded you so much. If indeed you are following it, it has upgraded you so much. And so I urge each and every one of you to go through these videos and these lessons well, and do this before you complete it with the AWS training we will give you. That training is also complete, but as a beginner, you just hear things, you don't understand them. All right. But after going through this in-depth training and adding that particular training to it, you will realize that whatever you will hear or whatever you will read, it makes sense. And now you are understanding and you are building the foundation to understand more later on. All right. So don't just chew for the exam. Don't just cram for the exam. Make sure you learn. And that is what we expect from you. So all our training here, they all come with quizzes. You need to take the quizzes and they are all part of the requirements. You need to take the quizzes to show that you have studied, and you will add additional resources from the AWS training website to add to it. And we have a practice test that you will take. After taking that practice test, we have reviewed it so much, and now it is very, very solid. After taking the practice test, going through this training, going through the additional resources on AWS, we don't recommend any other. This training, the additional resources on AWS that will be given, and taking the practice test, you will pass the exam. All right, you will pass the exam. Yeah, so let's focus on going through this lesson. And today's particular knowledge or today's particular lesson requires you to have some background in computer networking. And if you don't, you need to pay attention because we are going to give you that foundation of computer networking. And once you get it, once you understand it, that is what will give you the understanding. And together with the resource from AWS, will let you have the right understanding for the examination. Again, this examination is not just to give you a paper, a certificate, but to ensure that truly you have knowledge and truly you are prepared for cloud. Again, there are a lot of courses that they are very easy to go through, right? They are very easy to go through. What we have understood is that beginners, especially those who are not in tech or are now moving to tech, even though you hear certain things, you will learn certain things, the understanding is not really there. The understanding is not really there. And so it is important for you to build that understanding. And at Rita Africa, our training is designed to make that possible. All right, so I'm going to begin this lesson by playing a short clip. After the short clip, we will get right into virtual private cloud. If you can hear me and I'm audible, please type virtual private cloud in the chat for me.
Hi, I'm Dave Brown. Customers are bringing a wide variety of applications to AWS, each with the need to be highly available, highly scalable, secure, and service a global customer base. So over the years, we've been rolling out a global network that links all of our regions together to provide customers with a global backbone that effectively delivers application content to their customers. There's never a day where we're not thinking about what is the next thing that we need to be doing, the performance of our network, or the features that we provide to customers, or parts of the stack today that we could think about what is the next evolution from a scale and availability point of view. It's just continuous innovation and pioneering. The security is our #1 priority, and providing customers with a highly secure network and ensuring that their applications as well as their customers' data is secure is vitally important for the success of our business. The design of VPC has deeply thought about security right from day one to make sure that all network traffic within a VPC is completely private. We provide customers with a 99.95 availability SLA for EC2 today. Achieving that SLA requires a lot of deep thinking on the networking side. So we have several layers of redundancy all the way through our network to ensure that no single router failure could impact your availability. In the unlikely event that we do have a problem, we have a large team of engineers that are available to dig into the problem immediately, very often working directly with the customer and their engineers to ensure that we get to the root cause and resolve what may have been impacting their application. The performance of the network is also critically important for customers' applications. Over the years, we've continued to innovate on network performance through the innovation of our Nitro system, which allows all network processing to be offloaded to a dedicated processor on our underlying EC2 server. This guarantees levels of performance, latency, and jitter that are not achievable without this technology. We've learned a lot over the last 10 years in building highly available systems that really scale the globe. One of the key differentiators that we've done within AWS is providing strong isolation between our AWS regions. Now, that approach of strong isolation has been taken all the way from our availability zones through to our regions and really provides customers with a cloud infrastructure that they can rely on. I've enjoyed sharing a few details about the Amazon network with you and excited about what we're going to be doing in the years to come. Thanks for watching.
The internet is all about networking, and cloud computing is all about networking. For you to be connected to the internet, you are part of a network. So there's a whole lot of networking in the internet and in cloud. And AWS expects you to have some level of understanding of computer networking to be able to safely navigate and secure your resources in the cloud. Today's lesson on VPC will help you go to AWS and create your own cloud within the AWS cloud. Now, the AWS cloud is filled with customers from everywhere, the whole world. A lot of businesses are on the same cloud. But today's lesson will allow you to go there and create your own private cloud that only your resources exist in that cloud. When Amazon Web Services launched in 2006, they launched EC2 for compute, they launched S3 for storage, and they launched SQS for messaging. AWS has numerous services categorized in compute, and in compute we have EC2, we have Lambda, we have Elastic Beanstalk, we have ECS, we have EKS, we have Fargate and Lightsail, and all these we have covered. And what you have, the knowledge you've acquired from here is enough to get you ready for the examination. When it comes to their storage services, they have S3, Amazon S3, EBS, Elastic Block Store. I love that so much. We learned a lot about EBS. Amazon Glacier, EFS. I love EFS as well. Then we have FSX, and then we have Storage Gateway, which you will also know a lot about before the examination. When it comes to databases, RDS, my favorite, DynamoDB, so powerful, Aurora, so powerful as well. We have Redshift. I love Redshift because of the data analytics. We have DocumentDB. And for networking and content delivery, we have the VPC. VPC is going to be the main topic for today. And we are going to build a little foundation before we get into VPC itself. We have Route 53. We have CloudFront, we've talked a lot about. We have Direct Connect, which we'll hear about today as well. Then we have Amazon API Gateway. When it comes to management, we have CloudWatch, we have CloudTrail, we have Config, we have Systems Manager, and the very popular AWS organizations. By the time you are done with these trainings, you realize that you are fully equipped and you are very confident. All right? The practice test will help you understand the nature of the questions, how the questions will look like, and will help you be confident and be ready to answer them. Without a practice test, you may have a different approach to the examination, but with a practice test, you will have a feel of how the exam will look like. So let's get into networking. And to talk about networking for VPC, we want to begin with the concept of IP addressing and CIDR notations. Now, an IP address is an important concept in computer networking, and an IP address is what allows computer networks to communicate. Now, whenever we talk about networking, we are simply talking about connecting multiple computers together so that they will share resources, so that they will communicate, so that they can exchange information across and among themselves. Without networking, the world of tech will not get to where it is today. And networking is super, super important at the heart of computer technology, at the heart of innovation, at the heart of everything that the world of IT has got into today. Now, as a tech professional, you have to understand this basic concept of IP addressing. Now, when you belong to a network, you are given an IP address. Just like when you join a school, you are given an index number. On a network, you need an IP. Without an IP address, you are not known. There is no name for you. All right. So on a network, you are supposed to have something that we can use to identify you. So when computers join a network, they are all given IP addresses. The IP addresses are their names, the identifiers, what we use to address them. All right. Since they are not people and they are computers, we give them IPs. All right, we give them IPs. And the concept of IP addressing goes beyond just computers. Any device that is part of the networking architecture is given an IP address. The routers have their IPs, the switches have their IPs, the access points have their IPs, all the devices within the networking architecture, they all have IP addresses. And this is very, very important. And it is the concepts that forms the foundation of all of information technology and networking. So an IP address is a unique identifier assigned to a device on a network. All right. So again, a network is made up of multiple machines. Okay. A computer that is not part of a network is called a standalone computer. Please type that in the chat for me. Standalone computer. A standalone computer is a computer that is isolated from the rest of the world or from having any interaction with any other computer. You know, just as humans, we need people in our lives and we need to be part of a community. Computers also want to belong to something, a larger group to be more powerful. A standalone computer with all of its compute resources is not as powerful as a computer that is in a network. When a computer joins a network, it becomes more powerful. The computer can do more than a standalone computer can. If you are part of the internet, you are connected to a superpower that you can transform the world. If you don't have internet access, you are so isolated that even though you can have all the compute in the world, you can do very little. Imagine living with no internet. You can do very little and achieve very little. And what you can do with this powerful machine will be so limited. So people living in areas with no internet, they are really, really at a disadvantage. We need to have internet everywhere. When you hook up to the internet, you join a network. The internet is not the only network in the world. There are several networks. You yourself, you can create a network. You can take two computers and say, you two machines become a network and I'll connect you. So you need either a cable, you need other devices to make that possible. When you study computer networking, there are several ways of setting up networks. All right, several ways of setting up networks, and time will not permit us to go into the details. But once you join any network at all, whether you set it up, whether you set it up in a small office, you know, we can set up a network in a small office for all the computers in the office to communicate among themselves. We call that a local area network. And a local area network is a network can communicate amongst themselves, but does not mean they are part of the internet. The internet is also a network. The local network is also a network. All right. The local network is also a network. Some companies have set up networks that go beyond their office. I myself have actually connected a company that has multiple branches and connected their networks from one branch to another branch to another branch so that the branches can communicate. All right. So apart from a local area network that you set up within one office, when multiple computers are connected together in multiple offices, we have what we call a metropolitan area network. All right. That is if the network is across a whole city. What I mean by that is that if the other branches are not so close, they are far away in the city. They are close, sometimes they are close. If they are close and they are on the same compound, we call that a campus area network. All right. If they are far away within the city, then we call that a metropolitan area network. And if they are out of town, in a different country, we call that a wide area network. So the concept of computer networking is all about connecting multiple machines for a purpose. And the idea I want to give you is that the fact that a company can set up a local area network or a metropolitan area network or even a wide area network that can span across countries and even continents does not mean that that is the internet. That network that they have set up, that is wide area, that communicates across countries and continents, it is a private network. They are the only ones who have access to it. It is not the internet. If they want the internet, they can connect their network to the internet. So the idea of networking is simply about connecting your own machines for your purpose. And VPC that we'll be studying today is just like that. On the vast AWS network, you can go there and set up your own network for your own purpose so that all the machines that you provision from AWS or all the services that you use on AWS will operate within your private network. And this is very, very important. And it's one of the important things you need to do before you even set up EC2 instances. So every computer in the network has an IP address. And what we want to say is that an IP address serves two purposes. It identifies a device on the network and it provides a location for routing data. So your IP is your ID. Your IP is your ID. Without your ID, you cannot be identified, you cannot be known, and we will not know where to send your data to. Imagine a big house that has a router that is also an access point to share Wi-Fi, and everybody has, a lot of people have machines in it. Think of an office. There are a lot of computers there. Now, when you are browsing, do you know what happens? Your data, let's say you are on a website. Every request you make on your phone or on your laptop goes out of your building and goes out onto the internet and goes to a different country or wherever the servers are or the edge locations are, and pick the results or the data you are looking for or the request you made. A response is sent to you. That response will come into your company's router. That response will come into the building. And the question is, which computer made that request? All right, which computer made that request? Should the response be sent to a different person? No, the response is sent back to you. And all of that happens in a blink of an eye. You don't see, you don't know what goes on, but this is what goes on behind the scenes. And your IP address is what allows your system to be identified. There are types of IP addresses, and there are two main types of IP addresses. We have IPv4 and IPv6. The IPv4 looks like this. Please type this in the chat for me if you can see it. Please type it in the chat for me. That is how an IPv4 looks like. It is a 32-bit address divided into 4 octets, separated in dotted decimal notation. Thank you, Ato. Thank you, Caleb. And it supports approximately 4.3 billion unique addresses. All right. So this particular IPv4 was the first type of IP addressing system that was created. And each block of numbers, for you as a tech professional, you have to know that it is made up of 8 bits. All right. And if you study binary, which the seniors here have done, 8 bits has a range of 0 to 255. In total, making 256 because the 0 is also counted. So an IP address each block, each octet, we call that an octet. Like the 192 you are seeing is called an octet. That octet has a range of 0 to 255. It cannot exceed it. All right, because it uses 8 bits of binary digits. Binary digits is the same as bit. The 168 is also within a range of 0 to 255. The dot one is also within a range of 0 to 255. The last dot one is also in a range of 0 to 255. So if you tell me to tell you how an IP address looks like, it can be anything, just that they are in 4 octets, just that the range is in 0 to 255. So I want everyone to create an IP address, create a unique IP address. Just make sure you don't go beyond the boundary. Any IP address you create is correct. Let me see the first person who can create an IP address in the chat. So the first person to create an IP address, and all right, so thank you. Adejuni is right. Ato is also right. David is right. Marvelous is right. Dachomo is right. Ashinafi, perfect. You see, that is how it is. And this particular IP addressing, now, if you look at each octet being having a limit of 255, this 255, 255 or 256 from 0 to 255, you realize that it has a limit. All right. And so the numbers that you are all given, they are all within the range of IPs. But the fact is that the internet today has more devices now than there are people. Think about that. I hate to say that to my webmaster class. More devices now than there are people. And this particular system of IP addressing, the maximum we can have will be 4.3 billion unique addresses. Now, an IP address is supposed to be a unique identifier. And so if we have more than 4.3 billion computers, what are we going to do now? We have reached the limit. And so there are several solutions that have been put in place to ensure that networks are segmented so that each segment can also have its own range and a whole lot just to make sure we manage it. But still, this is a problem, and this is why the VCs was created. Now, the VCs was created in a way that right now it is absolutely impossible for us to have computers to make these unique identifiers. Because the V4 has a limit, and today, when it was being created, we didn't think we'll have that limit, but today we have exceeded that limit, so we need a V4. You will still see, we need a V6, sorry. You will still see V4 almost everywhere. Sometimes you see the V4 and you see its corresponding V6, but V6 is the future. V6 is the future. 10 years from now, I'm sure it's only V6 that we are going to be dealing with. And this V6 is a 128-bit address designed to address the V4 exhaustion, you see, or the V4 limit. And it is represented in hexadecimal notation. In our binary class, which all of you must take, you will learn that there are numeration systems in IT. We have the binary system, we have the decimal system, we have the octal system, and we have the hexadecimal system. And these are all systems of numbering. The IPv6 was created in the hexadecimal notation, and it supports vastly larger numbers of addressing, approximately 340 undecillion unique IP addresses. What in the world is undecillion? Undecillion is 10 raised to the power 38. So 340 undecillion computers. I don't even want to think of how it is. Do you know 10 with 38 zeros? Can you imagine 10 with 38 zeros? I don't know. If you start writing it now, I don't know when you end. I don't know if the world will ever get to 340 undecillion unique IP addresses. But this one has been created to make room for the future and the unimaginable future. So let's hope we don't have V8. All right. You'll still be working with the V4 all the time. I mean, today. And there are several ways of managing the V4. That is what you'll be seeing today. Maybe in 10 years' time, we'll not be talking about V4, but V4 is what you'll see today. And once you understand that each octet is made up of 8 bits, and once you understand that the numbers run from 0 to 255, I don't have much to tell you. It's like you giving these 4 blocks of numbers and you are told to give everyone a unique number set. All that we need to change is just one number. So someone can be 123.89.46.70. Another person can be 123.89.46.71. Another person can be 123.89.46.72. We just created 3 unique addresses. But we can create and create and create and change the numbers in each octet. And by the time we are done, we can create about 4.3, is it million or billion? 4.3, is it million or billion? What did I say before? Billion unique addresses. And each octet is 8 bits. So if you study binary, 8 bits can be 0000008 digits or 1111 8 digits. So between 000 and 11111, we can have 255 unique numbers or 256 from 0 to 255. Thank you. Now let's look at the concept of private IP and public IP addressing. This particular concept of private and public IP addressing has also helped a lot because if you create a private network like once created in a company, you are not using the IP sets that is being counted on the internet. Even though you are counting your own IPs, it is a private IP to your company. The internet also has its own, it's also free to start counting. Every network is also free to start counting. Now, a public IP address is a globally unique address assigned for communication over the internet, allowing your device to be accessed on the open internet. All right. So the public IP, think of the public IP is the IP you are given when you are online. The IP you are given when you are online. If you are in a company, I remember when we were working at TV3, we configure IP for every machine in the building. All right. But the IP we give you that you use to communicate internally, when you go online, the internet also gives you an IP address. And if you want to know your IP, you can go to what'smyip.net or .com and you can check your IP address, but that IP is your public IP because that is your internet IP. All right. You can switch from one telecom network. Maybe you are using MTN and Vodafone. You can switch from MTN to Vodafone, and you see that Vodafone's network will also give you a different IP. So a public IP is the IP that is assigned for internet communication. So when you are online, you use the internet IP. And the address given to you is the address that the internet will use to locate your device. So when something is coming to you, that address is for you. And so the device, your device will receive that communication. And that is what you use to communicate online. Remember, the internet is a network. And if you belong to a network, you need an IP address. The private IP address is used within private networks. not accessible by the open internet. So if you have a private network that is not the internet, the IP that you have is called a private IP address. If you set up an EC2 instance, you realize that the instance will have an IP that it can use for its internet communication. Because you need a VPC to set up an EC2, your own VPC also has its IPs. So your EC2 also has a private IP that it uses to communicate in the VPC. The VPC is an amazing system that has been set up by AWS. Allows you to have your own cloud that is shielded from the rest of AWS cloud. And you can communicate within your cloud and you can secure your own cloud. So this is an EC2 instance. And this particular EC2 instance, you can see that it is running. Later on, we'll be introducing the instance type like T2 micro. These are different from the instance types we learned. These are the actual machine instances and the names given to them. So later on, as you advance, you will look at them. So over here, this machine, you can see its public IP, and you can see that you can even open it because this is public. But you can also see that it has a private IP, and this particular private IP is meant for its VPC communication. All right. So AWS requires that you have this basic understanding because once you are working with AWS cloud, there's a lot of networking involved. And to secure your cloud, your VPC, you need to understand your IP addressing, you need to understand your own networking, and you need to understand your security rules. All right. So IPv4 private address ranges. Now, IPv4 are commonly, so IP addresses of networks are commonly allocated within specific ranges. So here we are talking about allocating addresses for private networks. Now, each designated for different network size as shown in the table below. All right. So the idea here is that every private network has a range of IP addresses you can use or you can set up. Okay. So all that we have said here is that there are ranges given to IP addresses. For large networks, they are given a range like this. You don't have to memorize them. You just need to understand that they have a range and they have a CIDR notation of /8. So soon we'll talk about the CIDR notation and you'll see. So over here, you can see that over here we have just 8 bits. We have just 8 bits. CIDR notation, we'll get into that later. Then for medium networks, you can see that they have 12 bits for notation and they have a range. Then for small networks, we can have 16, we can have 24 bits CIDR notation and they have the range. This is just to prepare your mind to understand that in networks, I talked about different networks and you can set up a lot of networks yourself. As a matter of fact, we have some type of networking we call personal area network. Personal area network is when you yourself hotspot to your phone, to your laptop, and probably to your tablet, and to your own private gadgets. You have created a network. That type of network is called a personal area network. So we have different types of computer networks that you can set up. And when it comes to issuing IP addresses, just understand that we have the concept of ranges that are given to certain types of networks. This leads us to CIDR notation, the bits I just mentioned. Now, CIDR is represented using CIDR notation, where IP address is written as a.b.c.d/n. Here, the ABCD is the base IP address of the network, and the n represents the number of bits, like the /n I mentioned previously, used for the network portion, leaving the remaining bits for the host portion. All right, so this is just telling you that when IP ranges are being created, there is a way we write them. The format that we use to write them is called a CIDR notation. And so we will give you a base IP address. We will give you a base IP address. Now, when we say a base IP address, we are just telling you that for your network, this is your mother IP. All right. So we call it the network portion. This is the mother IP. All right. And then we give you your CIDR notation, which represents the number of bits that are locked for the network portion. I'll explain this very soon. And any number of bits that you have on top of the CIDR number becomes the remaining numbers you can create for the devices in your network or for the host. So for example, this is the structure of the CIDR notation. So over here, you have been given this particular IP address as the network's IP address. So this is called the base IP address. This is the address of your network. Then you are also given a CIDR notation bits over here, the CIDR bits over here. Now over here, the 24 here simply means that 24 bits of your IP address is locked for the network or belongs to the network. We call it the network portion. All right. Now you see, this is 8 bits like we saw previously. This is also 8 bits. So 8 plus 8 is what? 16. This is also 8 bits. So 16 plus 8, 24. This is also 8 bits. 24 plus 8. Who can tell me in the chat? I don't know if your mouse is working. 24 plus 8. What is it? All right, thank you. So we said that 32-bit is the total number of bits of an IP address. So if you are told that your network has 24 bits locked, this simply means that the 24 bits is the network's IP and they are locked. All right. So what that means is that the remaining on top of the 24 becomes the numbers you can change. When we started the class, I asked you to create any IP address by changing anything. So you could change the 192, you could change the 168, you could change the 10, you could change the 25. Just that you know your limit was 255, but you were able to change anything. In a real network, you can't change just anything. You can only change what is on top of the 24, and the limit is 32, because the last end over here, we are talking about the bits, and we know that IPv4 has how many bits? 32 bits that you just put in the chat. And so if your CIDR block has 24 bits, how many bits do you have that you can change? Please tell me. If your network has 24 bits, how many bits do you have left that you can change? Ashnafi says 8. Excellent. So what this means is that when they ask you to assign an IP, you have no right to go and change the 168. You have no right to go and change this. You have no right to go and change it. The only part you can change is the last part, the host portion, and you have 8 bits to change. So if over here you have 25, then you can start changing from the 25. Even with that, there are some rules that we will look at. So if you are managing a computer network, let's say you are the network engineer of a company, and this is your CIDR notation, you know that you don't change the network portion, you only change the host portion based on the bits you have left. This concept of CIDR is a modern concept that is so powerful, and it allows us to eliminate the old structure that we had called IP classes. Previously, IP were in classes, class A, class B, class C, class D. But CIDR is a more flexible system for allocating IP ranges for computer networks. So every computer network needs its IP range. So instead of using the class system, CIDR stands for classless. Please type classless in the chat. CIDR stands for classless inter-domain routing. It is a method simply used to allocate IP addresses and define the range, the IP address range, and manage routing on computer networks to improve efficiency. It replaces the old class-based IP addressing system and introduces more flexibility and efficiency in allocating IP addresses for computer networks. For example, if you have this, it means this IP, the first 24 bits is reserved for the network, leaving the remaining bits for the host within the network. So this 24 means what is locked. And you know that the limit is 32. So if 24 bits are locked, then it means you have 8 bits to manipulate or to assign as unique identifiers. Because the idea of giving IP addresses, sometimes we assign the IP address manually. I remember when we were assigning IP addresses manually. Or you can use DHCP to assign it automatically. The CIDR notation tells our network our limit and the IPs we can create. So we've seen this already, and it's the same concept. Now, there's a website called CIDR XYZ, and this particular CIDR XYZ helps you to calculate your IP addresses based on your CIDR notation. So the CIDR notation that we had these IP addresses. If you visit this website, CIDR.xyz, and you input this, after this, I'll try it and we'll see. What is going to happen is that because 24 bits are locked, you'll be given this as your net mask. or subnet mask. Okay. As in the concept of subnetting, which we'll be talking about soon. This means you can see that the first 3 set of bits, they are all locked. The first 8 bits is up to 255. It means you can't change. You can't add more. We have reached the limit already. The second one also 255. This one also 255. So this is what is left. This means that this is where you can make your changes by increasing this and setting your IP based on this. So this concept is a different concept called subnet mask, which we'll mention later on. But it's the same idea of this, meaning the 24 bits are locked and we have only 8 bits left. All right. Now, if you are given this particular CIDR block of 24, it means you only have 8 bits. Now, 8 bits, we said it counts from 0 to 255. And this means that you have only 256 IPs that you can allocate. So your network has 256 IPs. All right. Now, out of the 256, there is the first one, the very first IP is called the CIDR base IP. That is 192.168.10.0. This becomes a CIDR base IP. You know, you have 256 left or 8 bits left. 8 bits is the same as 256. All right, please watch this. All right. So if this is your CIDR notation and you have 256, the first one is called your base IP. And we'll read a little bit about the base IP. You cannot use the base IP. Then the very last number, if we have 256 and we start from 0, what will be the last IP number we can use? Who can tell me in the chat? What will be the last one? We have 256 from 0 to 255. Good. Thank you. Thank you. You guys are following. Now, the last IP you can use is also reserved. It's called your broadcast IP. It's called your broadcast IP. So the first and last are reserved. This means how many do we have left to use? How many do we have left to use? Out of 256, 2 of them are locked. Good. So your first usable IP becomes 192.168.10.1. This is the first you can use. And you can keep assigning to all the devices in your company. All the devices, you can give them IPs, but the last one will end at 254. So this is how the IP addressing works and how the CIDR notation works. Now, the CIDR base IP is the first IP in the range defined by the CIDR block. It identifies the network itself and cannot be assigned to a device. It represents the starting point of the network, and it's also known as the network address. So this means that the first one cannot be used. The second one, or the last one, is called a broadcast IP, and is the last IP in the range defined by the CIDR block, and it is reserved for network communication purposes. It's reserved for communication purposes and cannot be assigned to a device. Now, this one is the first usable IP that you can assign in the network. It is the IP address immediately after the base IP, and the purpose of this in the range that can be the first IP in the range that can be assigned. That's the purpose. So you can assign to a computer, you can assign to a server, you can assign to a router, you can assign to any device within the network. Then we have the last usable IP, and this is the last assignable IP address within your network. It is the immediate IP before the broadcast IP. It's the final IP that can be assigned. All right, so let me quickly open this website and we will just try one example and see how it works. Please type the website address in the chat for me if you got it. So the website address, like you can see here, is CIDR.xyz. CIDR.xyz. Thank you. So over here, if I type 192.168.10.25, and I say that we have a block of 24, you can see that the same bits we are seeing here, the same IPs we are seeing is the same we saw in my slide, and we have 256. Now, to understand the concept of CIDR notation, I'm going to test your knowledge of this, because this over here represents the network portion, the bits of the network portion that are locked, that cannot be assigned. So let's change this to a different number, like let's try 28. Now, if we try 28, how many bits are left for us to be able to assign? Just know that the limit is 32. How many bits are left for us to assign? 4, right? Now, if you have 4 bits, and if you have done binary, 4 bits means from 0000 to 1111. We call that 4 bits. Now, to be able to use 4 bits, the possible numbers that can fill from 0000 to 1111, they are 16. They are 16. So this means that 16 belong to the host portion. 16 IP addresses are left for you to assign. You have 4 bits for the host portion, 4 bits for the host portion, and you can only get 16 IPs. Now, out of the 16 IPs, how many can you use? Who is following the lesson? Out of the 16 IPs, how many can you use? You can use 14, because your base IP will become the 16, and the last IP will become 31. So you can start using from 17 to 30. And if you count this, there are 14 IP addresses that you can use. All right. I want us to relax our memories a little bit. Let's go through this video and let's pick some point from here that will help us understand VPC very well. And after that, we will continue. And after we explain VPC, you will fully understand it. You'll fully understand it. So I want you to take some time, just go through this video and just pick information from the video. After that, we continue with the lesson and we will get a full understanding of everything that AWS requires of cloud practitioners. So let me share this video and we will watch it.
Hi friends, and thanks for tuning in. In this video, I'll cover the basics of an Amazon Virtual Private Cloud, or VPC. If you don't already know, Amazon has a massive global footprint with regions and availability zones all around the world, shown here. And as you can imagine, there's hundreds of thousands, even millions of customers using AWS every day. They're using EC2 instances and S3 buckets, databases, and so on. Check out my AWS playlist for more on those if you're interested. You don't want to just throw your resources out there with all the other millions of resources, a soup of servers and so on. Instead, you want your own little private slice of the overall AWS pie. And that's basically what a virtual private cloud, or VPC, is. It's your own private cloud or network within the cloud, within AWS. And it's how your resources are isolated from everybody else's resources. If we go out to the AWS Management Console and navigate to VPC, you'll see that I have one here. When you create your AWS account, you get a default VPC, and then of course you can create others. And if you're familiar with creating an EC2 instance, those are basically your virtual servers in the cloud. I'll just quickly go through a couple of steps in the wizard to launch one. Just select this one and configure instance details. You'll see here, this is where you select that VPC. So if I were to go all the way through and launch this instance, it would live within our own little private network in AWS. Now with that little teaser, I will say networking is a huge topic. It can be quite complex. There's actually an entire specialty certification that you can get for networking in AWS, so there's a lot to it. But for this video, I really just want to focus on the big picture concepts, especially for those of you who don't have a lot of networking in your background. I actually heard an analogy once that compared networking in AWS to a parking lot, which I found really helpful for understanding the core concepts. So let me share that with you. Here's a parking lot. You're all familiar. And outside of the parking lot is the whole world, AWS world, let's say. So the fence or border around the parking lot can be thought of as your VPC. It separates your resources from the rest of the resources in AWS. Up at the top here, we have traffic coming in from the outside world and traffic going out to the outside world. In AWS networking terms, this would be an internet gateway. That's how your VPC talks to the internet. And then inside the VPC, we have logically separated areas. For our example, we're going to say they're the left and the right of the parking lot. These are called your subnets in AWS networking terms, and generally they're going to be used for different purposes. Now, let's say that one subnet has a route, or a route, depending on where you come from, to get out to the internet. If that's the case, this is a public subnet. The other side, the subnet that doesn't have the route to the internet, that's a private subnet. And that's the main distinction. So maybe on the public subnet, you put servers that would host public-facing web pages, and in the private subnet, you would put your databases there. So there's that extra layer of security protecting from the outside world. Okay, hopefully that analogy was helpful for understanding the overall concepts of a VPC. Now let's combine that with knowledge of some of the things that you probably already know about the AWS infrastructure. First, we have a region. This represents a geographical location in the world, something like a US West 1 or EU West 2, for example. Then within that, you have availability zones. These are basically data centers within that region, and 2 or more per region, something like a US East 2A, 2B, 2C, and so on. Your VPC is tied to a single region, and it spans 2 or more availability zones. And then going down one more level, we've got our subnets. Again, those different partitions of your VPC. These are tied to the availability zone. So you have subnets for the first AZ and more subnets for the second AZ. They're public and private subnets like we talked about. And again, to reiterate, the main distinction there is that public subnets are accessible from the internet and private subnets aren't. And then within the subnets, that's where your actual resources live, your EC2 instances, and so on. Flipping back to the console really quickly, when you go to create a new EC2 instance, just as an example, you'll choose the network, which is your VPC, and then you also choose the subnet within that. So in this example, there's 3 subnets within this particular VPC. Now let's talk about CIDR. No, not that kind of CIDR. Classless interdomain routing, which I refer to as CIDR, though some people pronounce it CIDR or even CIDR, but regardless, CIDR. This is the notation used for describing blocks of IP addresses. An IP address, of course, is kind of like your home address, but for a computer. It tells the world where to find you. If we go back to the console, here's an EC2 instance that I created previously. You'll see the IP address here of 172.31.36.213. This IP address comes from our CIDR block, which is assigned at the VPC level. So back to the diagram. Like I just said, the CIDR range is assigned at the VPC level, and this tells us how many IP addresses we can assign to things within that range. So in this diagram, we have 6 EC2 instances, which would take up 6 IP addresses. Then if we added some database instances, those would need IP addresses, and so on. So we want to make sure that we have enough addresses for all of the resources in the VPC. back to the console. Again, we have this address here, 172.31.36.213, and you'll also see the VPC here. If I just open that up in a new tab and look at the details of that and switch over to the CIDRs tab, you'll see 172.31.0.0/16, which looks sort of the same, right? At least to start with, we've got the 172.31. Now, there's a lot to CIDR ranges and addressing and such, but let me make it just really, really simple. There's a site called CIDR.xyz. Let me bring that up in a new window, and I'll do a split screen here to make it easier to see. This is a really handy site to kind of help you visualize how these IP addresses work, how many you get, what your first address is, your last address, and so on. So over here, we're going to be working with this CIDR block, and let's input that over here. So we've got 172.31.0.0 and then /16. So this tells us that the first usable IP here is 172.31.0.1 and last usable IP 172.31.255.254, and that we have a total of 65,536 IP addresses that we can use within the VPC. So it's this /16 that's giving you that many. If you were to do something like a /24, you'll see that count drops. So /16 is giving you that 65,536. So looking at this instance that we saw earlier, here we've got the 172.31.36.213, and you'll see that falls within the first to last usable IP range here. And we obviously have plenty of IP addresses. We've got the 65,000 plus. We're only using one for this particular instance. So hopefully that makes things a little bit more concrete. Let me move back to the slides and cover just a few more concepts. We talked about the internet gateway that's at the VPC level, and the fact that a public subnet has a route to it, which is what makes it public. It's accessible to and from the internet. The private subnet doesn't have that route. You can't get to it from the internet, and you can't get out to the internet. But what if you do need to get to the internet for something, maybe to do updates or patching or download files or something like that? You still don't want the outside world getting in, but you need to get out for certain things. In that case, you want to use what's called a NAT gateway. NAT stands for Network Address Translation. Don't worry too much about that. Just know that you create a NAT gateway in your public subnet, and then you add a route from your private instance to it. Then you add a route from the NAT gateway to the internet gateway. So that's how you enable internet access for your resources in a private subnet. Okay, with those basics under our belt, let's do a quick discussion here of how to secure everything. We have network ACLs, or access control lists, and security groups. These are similar in that they both protect your AWS resources, but there's some key differences. A network ACL is basically a firewall that controls traffic in and out of a subnet. It's attached at the subnet level. You'll see that here in the diagram. It has rules for allow and deny, and those rules can only be used with IP addresses. So deny IP address from a known attacker, let's say. And then security groups, this is a firewall that controls traffic in and out of an EC2 instance. So down a level, as you'll see in the diagram. Here you can only make rules for allow, so allow traffic from other AWS resources, let's say. And in addition to IP addresses, you can also include other security groups here. So those are the basics of the Virtual Private Cloud, or VPC, in AWS. If you found this helpful, think about hitting that like button so it can spread to more people, and also consider subscribing for other technical tutorials like this.
Our goal here at Rita Africa is to help you get understanding. And so even if what we are teaching is new to you now, you will realize that it will build the first layer of the foundation you need. And as you progress, you realize that when you continue learning, because of that foundation, it will start to make sense and you understand it. Now, let's look at the concept of subnetting within the network. Subnetting is a process of dividing a larger network into smaller networks. When you have a large network, you can divide the large network into smaller networks. Each small network is called a subnet. Please type subnet in the chat for me. Please type subnet in the chat for me. Thank you. This concept is very, very important, and it ensures high performance of your network. And so if you have a large network, we expect you to break it into smaller networks. It also ensures security, because if something were to happen to your whole network, then your whole system is down. But if you have subnets and something happens to one of them, the rest will be okay. But if you didn't break them down, if something happens, everything goes down. In computer networking, this is a very, very important concept. And in AWS, you are expected to also have subnets within your VPC. It enhances network organization, security, and performance. Advantages of subnetting: it improves your network performance. Subnetting reduces traffic on the main network by allowing devices to communicate within smaller groups, making data transfer faster and more efficient. Imagine your communication is in the vast network. You have to travel from here to there, to there, to there, and it becomes so complicated. Sometimes if you are in a large group, sometimes you are not heard. Someone said that if you join a large corporation, it's good, it provides a lot of benefits, but you are not known, you are not considered, you are not heard, you are not even seen, you are just seen as a node. But if you are in a small group or a small company, especially a startup that has a great vision, you are important, you are known, you are heard. Someone says if you are in a mega church, you are not known, you are not heard, you are not seen. But if you are in a small church, you are seen, you are known, you are heard. Right. So if you break the network into smaller groups, communication between the groups, they are faster. The groups can effectively communicate. And even if you want to communicate outside that group, it is also fast than having the whole network in a large pool. Apart from performance, it enhances security. It segments sensitive areas of the network, restricting access and isolating potential threats. So once the network is segmented, certain sensitive areas can be disabled or enabled or restricted from certain particular types of access and isolated to prevent threats. It simplifies troubleshooting, localizing network issues within specific subnets, making diagnosing and resolutions faster. So if a problem happens, we just know that it's in subnet 1 or subnet 2, subnet 3, subnet 4. It allows you to pinpoint the problem and know where it came from, and you have fewer machines to deal with than the whole pool that you don't know where to start from. The last one I'm going to give here is about scalability. It facilitates easier expansion of the network by simply adding new subnets without disrupting the entire network. So the concept of subnetting is so important in computer networking, and it has a lot of advantages. There is something referred to as a subnet mask, and a subnet mask determines which portion of your IP address represents the network and which portion represents the host. So if you are given a subnet mask, like I mentioned before, like this, it corresponds to a CIDR prefix of /24, and this tells you the portion of the network or the portion of the IP that represents the network and which portion represents the host. So when you see a subnet mask like this, it tells you that this portion, the 2555 portions, belongs to the network or represents the network, and the 0 portion represents the host portion. And it is very similar to the concept of CIDR. Just a little different, because CIDR, although it also gives you the range, CIDR itself is not about dividing, but subnetting is about dividing based on the CIDR. So the concept of creating subnets or subnetting or creating smaller portions of your network or dividing your network, that concept is called subnetting. The CIDR notation, let's read about it. It says CIDR is a process of efficiently allocating and routing IP addresses using flexible prefix lengths. File subnetting, on the other hand, is the process of dividing a network into smaller subnets for better management, security, and performance based on the CIDR notation. So the CIDR indicates the network and the host portion of the address and the usable IP addresses. So the job of the CIDR is to indicate the range and indicate the network portion or indicate the IPs for the network portion and the usable IPs for the host portion. And it guides you to know how to divide a network. But CIDR is not what does the network division. It does not directly create subnets. So what creates subnets, or the process of creating the subnet, is called a subnetting. But CIDR allows you to do your subnetting. All right. Now it's time to get into Amazon VPC to wrap up today's lesson. So if you are here with me and you are still following, please type Amazon VPC in the chat for me. Amazon VPC in the chat for me. Thank you, Bernadine. Thank you. Oh, wow. All right. So since you are following, I'm going to play a short clip. And after this clip, we will continue with the lesson. Pay attention, listen to the clip, refresh your memories, and we'll talk about VPC to wrap up today's lesson.
Traditional on-premises network setups require high levels of attention and time to manage and validate. AWS networking solutions give you back your time by reducing network complexity, improving security posture, and providing you with the tools needed to monitor your network traffic. Get started by launching an Amazon Virtual Private Cloud, or VPC. You can easily select subnets, IP ranges, route tables, and security groups. You spend less time managing and verifying your network and more time building your applications. You can also use VPC flow logs or traffic mirroring to gain operational visibility, detect network and security anomalies, and troubleshoot issues. To meet your security needs, Amazon VPC provides advanced security features, allowing you to perform inbound and outbound filtering. And to secure your network connection while keeping your traffic on the AWS network, you can use AWS Private Link. Private Link establishes a private and secure connectivity between AWS services and your VPCs. AWS networking solutions scale as needed, even if you have tens or hundreds of VPCs. AWS Transit Gateway helps route all traffic to and from each VPC and provides you with a central console to monitor your connections. Start building a strong foundation today with AWS networking solutions.
All right. So to use AWS, you are supposed to have your own cloud within the AWS cloud. Your cloud is called your virtual private cloud. The moment you create an AWS account, you are given one virtual private cloud to use. You can create more. You can create many VPCs. Now, a virtual private cloud is a secure private cloud network that you create inside AWS for your own applications and the AWS services you use. So think of this as you going on to AWS and reserving or setting up your own cloud within AWS for your AWS services to operate within. Now, you don't have the keys to manage the entire AWS itself, but you have the keys to manage your cloud in AWS. Because you can create your own cloud, you are allowed to restrict it in a way that you can choose that nobody comes in there. Although it is AWS and it is public cloud, a lot of companies, a lot of users, the whole of the internet can go to AWS. Your availability on AWS can be private or locked. And you control what you let out or what you let in. This is called the VPC. It is like reserving a portion of AWS cloud and making it private and dedicated for your use, isolated from the outside world. All right. So the idea of VPC is so important that without it, it will be hard for you to control your sensitive data on AWS. There are a lot of companies on AWS that need certain restrictions and rules and their own configurations on how their cloud operates. And so the concept of VPC allows you to create your own cloud, and all the compute, database, storage, and all the AWS services you use can operate within the cloud, your virtual private cloud. You can create multiple and put your AWS resources in any cloud that you create. And any cloud that you create, you can give your own restrictions, you can give your own rules, you can decide how it operates. And companies need this for them to be able to configure their own policies to allow their applications to operate the way they want them to operate and how their resources are accessed on the internet by users. This is very, very important. So let me give you an analogy that I put in the lesson. Imagine a big hotel, and this big hotel is AWS. AWS is really huge. You can go to this big hotel and you can choose to reserve a room. Okay. Now, when you reserve a room in the hotel, although the room is part of the hotel and is owned by the hotel, the moment you reserve the room, it is private to you. You can lock it, decide that nobody comes in. You can do what you want. I don't know what you'll be doing in the hotel room, but it's your room in the big hotel. So think of AWS as this grand 5-star hotel, and think of your VPC as one room within the hotel. In that room, that is where you put your AWS instances and everything. And that is where you manage the securities and the controls and how something gets out of your room, how something gets onto the internet, how something comes in. You have full control over your VPC. And this concept of VPC is really, really good, and it allows customers to operate AWS really well. This network is separate from other AWS users and can be configured with specific security controls, ensuring that it is isolated from the outside world or the public internet, unless you choose to allow access. So this is so powerful. The idea of VPC is so powerful that you can choose what goes out and what goes in. And in the process of doing that, you may employ certain AWS services, okay? And you'll be hearing things like Internet Gateway. You'll be hearing things like the NAT Gateway, and you'll be hearing Direct Connect and different services, Route 53. And they all help you to decide how you restrict your system, your VPC. So think of VPC like reserving a room in a hotel just for you. The room is private and secure, and you have control over who can enter or leave. Just like the room is set aside for your use, the VPC, Virtual Private Cloud, is a dedicated space in the AWS cloud where you can run your applications and services isolated from other users. Do you understand the concept of VPC? Do you understand the concept of VPC now? Okay, so let me see in the chat. And the first person says, yes, sir. Thank you, Jael. All right. That is it. So all your AWS resources will live in your VPC. And this is very important to AWS to enhance security. And this is important to a lot of customers, a lot of companies. There are banks on AWS. There are serious companies on AWS. You see, when they were on-premise, they had special network engineers who did a lot of firewall configurations, a lot of policies, a lot of controls to ensure that their network is protected and secure. Now that they have come to AWS, they still need that level of control. So the VPC allows them to do their own configurations and set up their cloud the way they want it. So why do you use VPC? Number one, isolation and security. Isolate your resources for security and compliance. So your resources are isolated from the worst of AWS for security and sometimes for compliance. Then custom networking. Customize your network configuration the way you want. Scalability. Easily scale your resources within the VPC. Then hybrid connectivity. Connect your on-premise network to AWS. So you can connect your on-premise network in your physical company to your VPC on AWS. Because if you have a VPC, your VPC belongs to you. You can connect your local data center to your VPC and they can communicate and they can use those policies that you have set to decide what goes to the open internet and what stays private. This is so powerful. Without this, AWS will not be as secure as it is. When you create a VPC, you define the IP address range, the CIDR block. You see? So This is where the CIDR block we studied before comes in. When you create your VPC, you define a CIDR block or a range of IP addresses for your VPC network and configure other networking components such as subnet, routing tables, security settings to control traffic flow and access to your VPC. All right. What we are saying right now is that when you create your VPC, you define your range of IPs that a VPC can use. Number one, you also have to subnet your VPC. You also have to do what? Subnet your VPC. What is the concept of subnetting? Who can tell me in the chat? What is the concept of subnetting? Who can tell me in the chat? Who can tell me in the chat? Okay. So I can see someone typing. And the first person says that dividing your network into smaller networks, you see? So that idea of subnetting is so important. And so when you have a VPC, you have to subnet your VPC. And this allows you to even enhance the security and configure your private cloud in a more powerful way. In a more powerful way. In your VPC, your CIDR block in your VPC defines the IP address range for your VPC. So for example, if you have this VPC and CIDR block, it means 16 bits are locked and you have 16 bits. 16 bits can create up to 65,000 IP addresses. You see 24 bits locked and you have 8 bits. 8 bits can only create 256. But 16 bits is a lot and can create 65,536 IP addresses. And you can choose any valid IP address range depending on how many IPs you need for your VPC. All right, so when you define your VPC, you define your CIDR block for your VPC depending on how many IPs you want to assign within your VPC when you create it. Now, a subnet is a range of IP addresses within your VPC. What do you mean by a range of IP addresses? You see, once you have your whole set of IPs that you can use, like 65,000, you can create a smaller range for one set and create another range for another set. By creating these ranges, you are dividing the network or you are subnetting the network. All right. So a subnet in your VPC is a range of IP addresses within your VPC. Subnets are used to segment the VPC into smaller, manageable pieces and to separate the resources that you have on AWS based on security, accessibility, and several other factors. So you have seen how you can subnet within your VPC. Now, after subnetting, you can make some of your subnets public and you can make some of your subnets private. You see, once you have your VPC and you have full control over it, you have to intelligently subnet your VPC and hide some resources and make some resources public. Why are you on AWS? Maybe you have a web application on AWS on your EC2 and you have your VPC. If you block all access, can somebody view your website or web application? Yes or no? No, nobody can. If you block everything, all right, nobody can. So although your space is private, you can make some parts public, and certain things that you want them to go out to the open internet, and you want other people to be able to contact you on, you make those ones public. So the public subnets are subnets in your VPC that have been made public or configured to allow access to the internet. Again, you can choose to make everything private. But what is the use of going onto the cloud? For what you do, if you want to provide service to your customers, you need to allow them to reach you. But then you don't have to make your entire VPC public. This is why the concept of subnetting is so powerful and very important in AWS. You subnet your VPC and make some part private and make some part public. Configure them to allow access to the internet. They are typically used for resources like web servers so that your website people can visit the site. If you block the server, your web server, no one can see your website, your load balancers, and your NAT gateways, enabling them to communicate directly with the outside world. But at the same time, you have hidden a lot of your services in your private subnets. Now, private subnets are subnets not directly accessible from the internet. If you have a database, you have to put it in the private subnet. So how can the website access it? There are ways to do that. So when we get there, you see how even though something is private, you can allow it to fetch data to your public subnet so that your public subnet will send it online. Yes. Thank you, Ashnafi. And are typically used for resources like databases, internal applications that don't need direct internet access. They offer an added layer of security by keeping sensitive resources isolated from public traffic. This is so powerful. Wow. This is so powerful. I like the idea of private subnetting. And if you look at the architecture, this is how it looks like. Look at AWS as the bigger box outside. Now, your VPC is your own AWS. Let me not call it AWS. Your own cloud. That is your virtual private cloud. So what we are saying is that within your virtual private cloud, that is within the AWS cloud, you can create your subnets. And look at the resources that this company has. It has EC2 instances and it has databases. Why did they put the database? Did they put the database in the public subnet or in the private subnet? Who can tell me? Why did they put the database? All right. So someone says that they put the database in the private, but the EC2 instances, they made them public. All right. This is very powerful because this allows you to see the architecture of a company's cloud. If you go to AWS, you first need your own VPC and you need to create subnets, make some of them public and make some of them private. And some of your AWS services that you provision or you use, you can put some of them in the public and some of them in the private. Sometimes the ones in the private, we still need them, but there's a way we can connect to them, even though they are hidden from the open internet. So to learn how to understand all of these complexities, let's begin by looking at route or route tables. Now, a route table or route table contains a set of rules called routes that determine where your network traffic is directed within a VPC. Each subnet whether private or public, sorry, whether public or private, must be associated with a root table. All right, so just keep this in mind. A root table contains rules that determine where traffic is directed. Okay, where traffic is directed. If you studied about computer networking and you learned about networking devices like hubs and switches, you will learn that hubs are not intelligent at all. Even though they have ports that you can connect every computer to, they don't know which computer is intended to receive any communication or data packet. So if you use a hub to create a network, what will happen is that every communication will be blasted to all the computers. So when a computer didn't make a request, it will still receive data packets. And this creates a lot of congestion within the network. When computer networking started, one of the devices we used to be able to connect multiple computers was called a hub. After that, they invented something called a switch. I'm sure you've heard of the switch. The switch has a routing table within it. And it makes the switch very intelligent to know that this request was made by computer A and is intended to go to computer E. When computer E responds, the routing table determines which computer sent the request and which computer should receive it. So because of that, it keeps information about the various ports and the various devices, and it knows it has data of where it originated and its destination. There's a similar concept here. So there are a set of rules called routes or routes that determine where network traffic is directed in a VPC. This is simple. In a public network, traffic is routed to the internet gateway. Please type internet gateway in the chat. Please type internet gateway in the chat for me. Please type internet gateway in the chat. This is very, very important. All right. So based on the route table or route table, if you are having a public subnet or you have set one of your subnets to be public, traffic is routed to the internet gateway, allowing direct access to the internet. What this means is that when we said that the public subnet is public to the internet, what we didn't say is that they communicate through a gateway. There is a door or a gateway that public subnet communicates through. All traffic from your public subnet is routed through something called the IGW or the internet gateway. And the internet gateway is a gateway to the internet, and it allows direct access to the internet. If you are in a private subnet, your traffic doesn't go through the internet gateway, because the moment it goes to the internet gateway, it goes out on the open internet. But if you are in a private subnet, your traffic is routed through something we call the NAT gateway. In computer networking, NAT stands for Network Address Translation. So there's another gateway which we'll be looking at shortly called the NAT gateway. And traffic is routed to a NAT gateway for outbound internet access, ensuring that resources can access the internet without being directly exposed to the incoming traffic. To explain this, this is trying to say that if you are having your private subnet, although it is private, if you want something to go out, for example, the database that we have put in the private, we still need it. We still need the data on the website, all right? So how do we do that? We can channel the data through what is called a NAT gateway. And the NAT gateway is a special gateway that allows a private subnet to send data to the public subnet. Once the data gets to the public subnet, then it can go through the internet gateway and go out. But the NAT gateway is intelligent in a way that it only allows data out. So it is for outbound internet access. Please type that in the chat for me. Outbound internet access. Outbound internet access. Ensuring that resources can access the internet without being directly exposed to internet incoming traffic. This means that incoming traffic does not come to the private subnet, but if you decide that your private subnet should send data out, it will go through the NAT gateway to the public subnet, and then from the public subnet to the internet gateway before it goes out. So let's look at the internet gateway first. An internet gateway, or IGW, is a horizontally scalable, redundant, and highly available component that allows communication between your VPC and the internet. All right. So look at this. Its purpose is to allow communication between your VPC, which is private, your virtual private cloud, and the internet. But then it is communication from your public subnet that goes through the internet gateway. It enables resources in your VPC that are in the public subnet to access the internet, and it allows external users to reach those resources. So because it is you have created your public subnet, customers can also reach you, or your website visitors can reach your server. They can contact you, they can get to you because you are public, okay? And through your internet gateway, traffic can come into the public subnet. So let's look at how the gateway looks like. Let's say someone is trying to visit your website, and the person is sending a request through the internet to AWS. And you on AWS, where do you live? You live in your VPC, right? And you have your public subnet here. Now, the way people get to you is through the internet gateway, the IGW. And the way you also go out of your private cloud is through the internet gateway. Now, this is very important, and these are some of the things that the exam will ask you that if you didn't hear it in class or you didn't read about it, you will just not know what to select. All right. So over here, although these things seem complex, you can see that now they are becoming simple. So you have your VPC. We know that it is a public subnet that can go out to the internet, but they go through a door. That door is called the internet gateway. And this internet gateway is what allows the outside world to also reach you. And when the outside world reaches you, they don't reach your private subnet, they reach your public subnet, just like this. This diagram, is it clear to you? Let me know in the chat. Is this diagram clear to you? Because right now it looks very, very clear to me. I can see AWS, and I can see my VPC, and I can see my public subnet, and I can see my doorway to the internet. You know, your VPC is your private area. You can go out. You need a door to go out. And you need a door to allow your customers or your website visitors or your clients to also reach you. That door is called the internet gateway. There's another door called the NAT gateway. Let's look at the NAT gateway. A NAT gateway, network address translation gateway, enables instances in a private subnet to access the internet. How? At the same time, keeping them secure from direct inbound internet traffic without exposing them directly to the internet. This is very powerful. Look at how the NAT gateway works. Let's read this first. It says that a NAT gateway is usually deployed in a public subnet. This is why when I was explaining, I said from your private subnet, it goes to your public subnet before it goes through the internet gateway to the internet. The NAT gateway is usually deployed in a public subnet, as only public subnets can have access to the internet through the internet gateway. So look at your private, your databases are here. You see, you have one private that you didn't even allow any access. That is very good because you can keep some of your resources here that you don't want anyone to have access to. But if you have some important things in the private subnet, like your database, that you want to provide access to your website, you can use this thing here. This thing that you are seeing here, this icon here. Who can tell me the name of this icon? Who can tell me the name of this icon? This icon here. Who can tell me the name of this icon? The name of this icon is your NAT gateway. Thank you, Ato. Thank you, Valentine. That's your NAT gateway. So look at what a NAT gateway does. The NAT gateway is able to access the private subnet and pull something into the public subnet. And you can see that the NAT is also deployed in the public subnet. The NAT is not deployed in the private. The NAT is deployed in the public. And the NAT can contact the private. After the NAT contacts the private, you can see that whatever is in the after the NAT contacts the private, it moves whatever you need to the public subnet. And from the public subnet, you can see that something can go out to this icon here. Who can tell me the name of this icon? Who can tell me the name of this icon in the chat right now? Who can tell me the name of this icon? It's the same thing we discussed. It is called the Internet Gateway. Thank you, Ato. Thank you, John. Thank you, Okello. Thank you, Jael. Thank you, Valentine. All right. So now, do you see the difference between the Internet Gateway and the NAT Gateway now? You can see how they work. These are some of the questions that you'll be seeing in the examination. You see? So if you didn't understand all these things, then you'll be confused. There's also something called elastic IP. An elastic IP is a static IP address designed for dynamic cloud computing. Elastic IPs are used to assign a fixed IP address to a resource, such as an EC2 instance, for use in your virtual private cloud. Elastic IP addresses are used when you need a permanent and publicly accessible IP address that will remain consistent even if the underlying EC2 instance is stopped or started. So sometimes in your EC2 instance, you see that there is an elastic IP. So the elastic IP is a permanent IP. It's a permanent IP. They are used to assign a fixed IP to a resource, such as an instance, EC2 instance. And this fixed IP is like a permanent address that will remain permanent to that resource, whether it is stopped or on. One thing about IP addressing, one day you can test it. You can take your phone, if you have two SIM cards, connect to SIM 1 and check your IP. Then connect to SIM 2 and check your IP. You realize that anytime you make that change, you get a different IP. Sometimes, even if you restart your phone, your network can assign a new public IP. So a public IP, the real world, you can see that it can change. But there's something called elastic IP that is permanent in your VPC, right? Let's keep that way. Now let's talk about what is called a virtual private gateway. Today we've talked about two gateways already, the internet gateway, and we have talked about the NAT gateway. The virtual private gateway is a component that allows you to connect your VPC to your on-premise network via a VPN connection or via AWS Direct Connect. So the AWS Direct Connect that we've been seeing, this is how it is used. You have your VPC in AWS, your virtual private cloud. Before we started this lesson, we said that you can connect your on-premise resources or network to your VPC. How do you do that? You can either use a VPN connection or use the service called AWS Direct Connect. That is what it does. So the virtual private gateway is a component that allows you to connect your VPC to your on-premise network, either using a VPN connection or the AWS Direct Connect. If you use a VPN connection, if you have an on-premise network and need to securely connect to your VPC, you can use a VPN connection. The virtual private gateway establishes a secure communication channel through the VPN to your VPC and your on-premise data center. You can also use Direct Connect. For high bandwidth, low latency connection, AWS Direct Connect can be used to connect your on-premise network to your VPC. So in our introductions, we always see Direct Connect. This is how it is used. Once you have your VPC, you can use Direct Connect to connect your private resources to, or your on-premise resources outside of AWS to AWS into your VPC. So over here, we have your company's data center here, your on-premise resources here. We have AWS and your VPC and your subnets here. Now, this private gateway allows you to connect your on-premise resources to your AWS. Again, this time we are not talking about going to the internet. Here, we are saying that if you want to create a secure connection between your VPC and your local on-premise resources, there is another gateway. This is not the internet gateway. This is called virtual private gateway. There's another door for that. This door is secure and protected. Remember, we are not going to the internet. Here, we are going to your office, and we want a very, very secure channel to connect your office resources to your AWS resources. Use a virtual private gateway. And you can either do that through the VPN connection or through AWS Direct Connect. Last but not the least, we talk about security groups. And a security group acts as a virtual firewall. So I think there are two things to talk about. Now, when we introduced VPC, we said that your VPC needs a lot of security, a lot of settings, a lot of configurations. One of them is called a security group, and this is actually a firewall. And this firewall, you use it to control inbound and outbound traffic to your AWS resources, like EC2 instances within your VPC. All right. The fact that your public subnet is open to the internet does not mean anything should be able to reach it. The fact that you have made your subnet public does not mean anyone can come in, even though you've allowed your customers to come in. You allow your website visitors to come in, all right. But you need to create a firewall. And if you understand the concept of firewall, a firewall can restrict incoming traffic and allow safe traffic. So you can use security group to create a firewall to control traffic coming in, called inbound traffic, and traffic going out, called outbound traffic within your VPC. Now, security groups, one of the questions you see in your exam, this one I'm sure it will come in the exam. They will tell you whether your security groups are stateless or stateful. So what do you see about security groups? Are they stateless or stateful? Security groups, are they stateless or stateful? So security groups are stateful, meaning that any allowed inbound traffic automatically allows the corresponding outbound traffic. What does it mean? This means that it remembers the states. So if it allows you in, it means when you are going out, you are free to go out. That means it remembers you. Okay, you see this VPC idea that we talked about. Right now, we are talking about how to protect it. We said that your VPC can be public. You can create your public subnet. But how do you protect it? You need a firewall. Without a firewall, anybody can come in. All right. So the job of the firewall is to filter what can come in and what can go out. That's the job of the security groups. Now, the security group, one feature or one attribute of the security group that you need to know, I'm pretty sure that you see this in your exam. Is that the security groups are stateful, meaning any traffic that is allowed automatically allows the corresponding outbound traffic. That means when you come in, you are free to go. It's like having your passport and entering into a country. And this particular country, so long as you are allowed in, you are free to go out. Or let's talk about there are some places you need a ticket to go in, and there are bouncers and there are people outside, like a stadium or whatever you are thinking about. If it is stateful, it means that we only check when you are coming in. But going out, we remember that you came in and you can go out. But there is something else that we'll talk about. That one is not stateful. That is where the exam trick will come in. That one, you will know that we check you left and right. So we'll talk about that one. That's the last thing we'll talk about and we are done. So let's go back to your client coming into your VPC through the internet gateway. And this guy here, we'll talk about him before we end the class. But in your public subnet, we have security groups that will allow or deny traffic. This is what allows or denies traffic. But then we are saying the security group here, it is stateful because if it allows traffic, the traffic is free to go back. The last thing we'll talk about is called Network Access Control List, or NACL. A network ACL is a stateless. You see, this one is not stateful. This one is stateless. Firewall. It's also a firewall that operates at the subnet level. Unlike security groups, which are stateful, NACLs require both inbound and outbound traffic rules to be explicitly set up. What this means is that your NACL will check you when you are coming in and check you when you are going out. When you are coming in, you are inspected. When you are going out, you are inspected. So there are two types of firewalls that you have, your security groups and your NACLs. Your NACL is stateless, meaning it doesn't remember that you came in. It doesn't remember. That's why it is stateless. It doesn't keep your state. But the stateful will keep your state and knows that you came in. So if you are going out, we know you. But the NACL, when it allows you, it forgets about you. If you are coming again, we'll check you again. That is how it works. So your NACL and your security group allows you to build strong security within your VPC. And although you have an internet gateway, you can still filter everything and protect both your public subnet and your private subnet. This is the end of the class. And if you have learned something today, let me see in the chat. All right. Thank you so much. This is an important lesson, and we are so happy that we have been able to do justice to it. Now, when you go onto the AWS channel and you are learning about this, you remember everything I said, and you now realize that you are understanding. Learning is in layers. If you're a beginner, you can hear a lot. You can hear so many things, the right things, but the understanding. There are certain things that in the past, when I was learning them, it took me about a month to understand it. But later, when I understood them, it's like I realized that you can finish it in 2 hours or 3 hours. The whole thing that you use 1 month to study, you can finish in 3 hours. Because now you understand it. You see, if you have a background, it is different. You can see content, but the way your brain takes it, the kind of understanding that you need for it to settle in, it takes time for that to build, and it takes several layers for that to happen. So thank you all for joining us in this class. This has been a wonderful class. And again, congratulations to our first certified cloud practitioner, Benedino KK. You've made us so proud. We're so proud of you. And we want to encourage you to keep on working hard, keep carrying the torch of motivation and hope to shine and light up Africa and lead the way and make everyone also achieve their dreams through your hard work and your determination. And I pray for God's blessing and success to be your portion all the days of your life. So thank you all for watching. If you missed any lesson, go back and watch the previous lessons. Make sure you have this understanding. And there are some additional resources on AWS that you need to cover to be ready for the exam. Once you cover this and you cover the AWS resources, no matter where you come from, you will understand and you'll be able to pass the exam. So thank you, and I'll see you in the next lesson. Bye-bye.